Hi, I am going to present our work on deep transformation-invariant clustering. Why do traditional clustering algorithms fail on images? If you look at standard clustering algorithms, they typically rely on distances, which are not invariant to image transformations. Even in the simplest case of translated images, resulting L2 distance is not informative if images are not aligned. And this observation holds for more complex image transformations. For this reason, most image clustering methods perform clustering in a meaningful feature space. In this work, we instead propose to explicitly resolve transformation invariants in pixel space, with a clustering approach that jointly learns prototypes and prototype-to-sample alignment using deep learning. Prototype-based clustering methods typically aim at learning a set of prototypes by minimizing a quantization error. Once the problem is solved, each sample is then assigned to the closest prototype. Our key insight is to explicitly model transformations, in this case a rotation, to which we want to make the clustering invariant. For each sample, we first predict alignments of the prototypes, then use the transform prototypes to compute the quantization error. We propose to predict alignment using deep learning and to jointly learn prototype and deep alignment by minimizing a single quantization loss. We model complex image transformations as a sequence of transformations. For example, on MNIST, we first learn to predict affine transformation, then refine the alignment using morphological and spline-based transformations. When we apply k-means to standard datasets, we observe that results are mainly driven by color or spatial biases. By explicitly modeling color and spatial alignments, our method obtains much greater results both qualitatively and quantitatively. In particular, we improve state-of-the-art on both Fashion MNIST and SVHN datasets. We also demonstrate its robustness by visualizing clustering results on real photograph collections. Except few outliers, the clusters found have a surprisingly high purity. Even for such complex images, we managed to model real transformations like illumination variations and viewpoint changes. Finally, we showed that our clustering method could be applied to unfiltered sets of Instagram images to discover iconic photos and iconic poses. In this work, we introduced an efficient clustering approach, which jointly learns prototypes and transformation-invariant assignments to match data. Although conceptually simple, our methods comes with several advantages, including a strong interpretability of clustering results. Check out our paper for additional experiments and details. Thanks.